Greetings everyone, this is Mr. Molar, and I'm going to go over a couple of things that are going to help you on practice number 2. I'm going to do the first problem completely using those new equations from the colligative properties, and then I'm going to do another problem and give you some hints for this worksheet. So we're going to start off with question number 1, and question number 1 is asking for how do the freezing point and boiling point change for my solvent when I've added a specific solute to it. So the first thing you need to do is you need to figure out, okay, well how much solute did I add, and how did that change the concentration of my solution? And so to do that, I look at the question, and it says I have 45 grams of sodium chloride. So I went and did on the side here, I added the molar mass of sodium chloride, and I got the molar mass was 58.5. So I multiplied the grams times the molar divided by the molar mass, and we were able to get to 0.770 moles. And so to find the concentration, the first part I want you to do is find the molalities. Molality is just the number of moles divided by the kilograms of my solvent. So I take that number of moles, 0.770, I divide it by 0.500 kilograms. Now I get that number from the fact that I dissolved it in water and there was 500 grams, but it must be in kilograms of water. So I divided 500 by 1,000 in order to convert that to kilograms, and you must do that. So once I've done that, there's my molality for this solution. So now we're going to take up this problem and divide it into two pieces. We need to solve for what is my new freezing point and what is my new boiling point after I have put the solute in there. So let's start with the freezing point of the solution. I've written the equations up on the top here that you're going to be using to find the new freezing point of the solution and the new boiling point. So there's my freezing point. And so what we need to start with is we need to know the freezing point of the solvent, whatever that solvent is. In this case, it's water. And so I look in the problem. Well, there it says freezing point of water, 0 degrees Celsius. And then I also need to know this little delta TF, the change in temperature due to the solute I've added. So we're going to start there. We're going to solve for delta TF. So the change in temperature of my freezing point is equal to my Kf times my molality times that Van Hoff factor. And so what I can do then is I can look at what the problem gives me. They give me Kf for water. There it is, negative 1.86. So I'm just going to plug these numbers in, literally. Delta Tf is equal to negative 1.86 degrees C per m. Multiply that by the molality we just calculated, and then multiply that by the Van Hoff factor. Now when I look at my solute, I notice it's sodium chloride, which is NaCl. Because this is an ionic compound and it breaks into two pieces, Na plus and Cl minus, my I is going to be equal to 2 for this one here. So I'm going to put a little 2 out in front. There we go. So when I plug this into my calculator, I'm going to find that the change in temperature is equal to negative 5.7 degrees Celsius. Now that I found that change in temperature, I can find now the overall change in the freezing point of the solution. So my new freezing point, after I've thrown that stuff in, is equal to the old freezing point of the solvent, which was just 0 degrees Celsius given in the problem, plus the change in temperature. Now it turns out that this change in temperature is negative because it actually has to be colder. So that's totally fine. Add a plus negative 5.7 degrees Celsius. The freezing point is always going to be depressed, so this will be a negative number. So when I subtract that, I'm going to get that my final freezing point was, should be a 0, sig figs here, negative 5.7 0.0 degrees Celsius is my new freezing point solution. Now when I'm looking at the math, the 2 is a chart value. It's just a perfect number, so I don't need to worry about sig figs for that one. The 1.86 is a chart value. The 1.54 came from my molality, which came back all the way to my 45.0 grams. 45.0 grams. Okay, so this is my new freezing point of my solution. It was depressed, it got lowered. Let's look at the boiling point of the solution. I'm going to look at the other equation I've written up top here. And so I need to find the new boiling point. This is boiling point elevation. So it's going to boil hotter. So to find that, I need that little change in temperature B. So I'm going to go ahead and calculate the change in the boiling temperature is equal Kb times m times I. And so when I plug these numbers in, the Kb for water is 0.51 degrees Celsius per molality, multiplied by my molality, which I calculated earlier, was 1.54, and then multiply that by I for this compound was 2. And so I can find my delta Tb. It's going to be equal to, when I punch this in my calculator, 1.60 degrees Celsius. And remember that the 0.51 is a chart value, so don't worry about the 2 sig figs on that. And then to find my boiling point of my solution, I take the original boiling point of my solvent, and that's going to be for water 100 degrees Celsius given in the problem. So 100 degrees Celsius plus my 1.60 degrees Celsius, and that's going to give me 101.6 degrees Celsius is my new boiling temperature. And so we have that boiling point elevation. Now as you go through this, the first ones are kind of straightforward. I'll give you a couple hints on here. AlCl3, when I think for what my I is, I see that that's going to break into 4 pieces, an Al plus 3 and 3 Cl minus 1s. So keep that in mind. For number 3, the question is actually asking you to solve for the molar mass. And so I'm going to have to take the number of grams divided by the number of moles. And I'm going to need to somehow solve for those things. Now they give me grams in the problem, so I just need to find N, or the number of moles. You're going to have to work backwards here, because it says the solution has a freezing point of negative 0.93. And so the new freezing point of my solution, this is after I've added stuff, is actually given in the problem, and it's going to be at negative 0.93 degrees Celsius. You kind of have to work backwards, knowing that water normally freezes at 0 minus some change in temperature freezing. Those values are going to have to equal this new freezing point, which was 0.930 negative. So you're going to solve for this little unknown over here, negative delta Tf. So delta Tf is equal to 0.93 degrees Celsius. And once you know that, you can go back and solve for the molality. And then once you know the molality, you can take that molality, which is just the number of moles divided by the kilograms of solvent. And once you know what your molality is, you can rearrange this and solve for number of moles, which is going to help you come back here and find the molar